In this video, we're going to look at an example of calculating the Pearson correlation coefficient, otherwise known as the product moment correlation coefficient. Now, there's a few different formulae that you might see in this calculation, but we're going to look at this one that's at the top of the page. R equals SXY over the square root of SXXSYY that I've circled, and the definitions of SXX, SYY, and SXY are given to the right. Now, in this video, I'm going to go through the long way, like the full calculation. If you have a calculator with a stats mode, then you should be able to enter your data into a stats mode, and it should be able to tell you the values of each of these things, SXY, SSX, XYY, etc. But we'll do it in full ourselves now. So here's our example question at the bottom. It's to calculate the value of the product moment correlation coefficient between purchase price and auction price for what look like 6 items. So in order to use this formula, we need to work out these things. I'll just underline them. We need to work out the sum of x squared, the sum of y squared, and the sum of xy. And those things aren't in our table. So we're going to add 3 columns to our table for these columns, which are going to be, let's just set this up. Okay, that's good enough. So we're going to have a column which is our x squared values, a column which is our y squared values, and a column which is our x values multiplied by our y values. So let's just fill this in. So x squared, when x is 20, x squared is 400. When x is 35, x squared is 1225. X is 18, x squared is 324. X is 50, 2500. 45 squared is 2025. And 55 squared is 3025. So that's my x squared values filled in. My y squared values, 30 squared is 900. 45 squared is 2025. 25 squared is 625. 50 squared is 2500. 38 squared is 1444. And 45 squared is 2025. Okay, now we also need to work out the product of x and y. So for example, 20 times 30 is 600. Then we're going to do 35 times 45, which is 1575. 18 times 25, which is 450. 50 times 50 is 2500. 45 times 38 is 1710. And 55 times 45 is 2475. So those 3 columns are now completed. Now we also need, for all 5 of our columns, we need to work out the sum of the column. So the sum of the x's. So if I add all of those x's together, I get 223. If I add all the y's together, I get 233. If I sum my x squared, so add 400 plus 1225 plus 324 and so on, I get 9499. If I do the same for my y squared, I get 9519. And finally, for my xy's, I get 9310. Okay, so we've made a decent amount of progress. We filled in all our sums. We can now work out what SX, X, SYY, and SXY, etc. are for this question. So let's just go back to these formulae at the top. In this example, SXX is the sum of x squared, so we worked that out, that was 9499, minus the sum of x all squared. Well, the sum of x is 223, so you get 223 squared divided by n. Well, there's 6 data points, so it's 223 squared over 6. We get 1210.83. Okay, we're going to do the same for SYY. Now the sum of y squared from my table is 9519. So then I have to take away the sum of y squared, which is 233 squared divided by 6, which gives me 470.83. And finally, SXY, I need the sum of x times y. Well, that was 9310. and I have to take away sum of x, that's 223, times the sum of y, that's 233, divided by n, that's 6. And if I work all of that out, I get 650.17. Okay. Now, finally, we just have to plug these numbers into my formula for R. So I'm just going to move this down here. So R, which is my correlation coefficient, is SXY over the square root of SXX SYY. And we worked out all of these things. The thing on top, SXY, is 650.17. We're going to divide that by the square root of 1210.83, and SYY is 470.83. And if you plug that all into your calculator, you get an answer, a correlation of 0.861. Now, first of all, we just dummy check that's a reasonable answer. Remember, correlation is always between -1 and +1, so 0.861 does indeed seem reasonable. We've got a positive number close to 1, so that shows in this example we have a strong positive correlation between purchase price and auction price.